All right, we're back. We are on page 29 of math analysis, and we are going to talk about some even and odd functions now. So this is one where you gotta really remember some stuff. Also, I'm just going to tell you something because it's rough to figure out in any way other than by testing points, and that's not what you should really do. But each of the trig functions is either even or odd. We're going to decide which is which. And what we're going to do is we're going to just pick points and see how it goes. What I want you to remember is I want you to remember the rules, right? So the first rule, I like to start all of them with f of negative x. So even function. So that's going to be f of negative x is equal to just f of x, right? So if f of x equals x squared, f of negative x is quantity negative x squared, which is x squared, which is f of x, therefore even, right? So that's the rule for even functions. Now odd functions, again, we start with f of negative x, and that should give you the opposite of f of x. So what's a good odd function? Let's use f of x equals, I don't know, x cubed is odd. All right, so I'm going to find f of negative x. That's negative x and then cubed, which is negative x cubed, which is the negative of f of x. Therefore, odd, right? So that's what you should do. The problem with a trig function is if someone said, you know, f of x is sine of x. So then f of negative x is sine of negative x. But like, what do I do? There's no rule for that I'm aware of yet. So there's not much I can do. So what I'm going to do is I'm just going to investigate with some specific values, right? So I do know a lot of values of sine at this point, like a lot of values. So let's actually fill some of those in. So pi over 6 is going to be 1/2, a root 2 over 2, radical 3 over 2, 1/2 again, negative 1/2, negative root 2 over 2. We're doing sines all the way through here. Negative root 3 over 2, negative 1/2. So those are my sine values. Okay, so now let's think about something. So sine of pi over 6 versus sine of negative pi over 6. What I want to do is I want to think about this kind of visually. So I'm going to actually start with, so not a lot of room, so good for me. I'm going to try to draw something that I think is useful, right? So something I think is useful. If I start with a quadrant 1 angle, right, pi over 6 would be here, right? So that's pi over 6, that's quadrant 1. Negative of pi over 6 takes me to quadrant 4. Okay, so now I know that the absolute value of the sine of pi over 6 and the sine of negative pi over 6 is going to be the same because they're the same distance from the x-axis, so their y values will be the same on the ordered pair, and that means their sines, the absolute value of their sines is the same. But here, I'm going to get negative 1/2, right? Fourth quadrant, sine is negative. It's another way to think about it. So quadrant 1 goes to quadrant 4. In quadrant 1, sine is positive. In quadrant 4, sine is negative. Now, will that change? Pi over 4, quadrant 1. So the negative of that ends up in quadrant 4, which means negative root 2 over 2. Quadrant 2. All right, so quadrant 2, let's say it's like here. So a quadrant 2 angle, if I rotate the negative of that, it's like by symmetry, you're just reflecting over the x-axis, will end up in quadrant 4. So quadrant 2, sine is positive. Quadrant 4, it's negative. So I'm still going to get this. 5 pi over 6 is quadrant 2. Sorry, I think I said quadrant 4. I meant quadrant 3 on the last one. I may have said quadrant 4 a lot, actually, now that I mentally think that through. Who knows? 5 pi over 6 is quadrant 2. Sine is positive. The negative of 5 pi over 6 puts you in quadrant 3, where sine is negative, so this will be negative 1/2. 7 pi over 6 puts you in quadrant 3. If you rotate the negative of that, so the negative of 7 pi over 6, that puts you past negative pi by by pi over 6. That puts you in quadrant 2 where sine is positive. So this is going to be positive 1/2. 5 pi over 4, same story. 5 pi over 3 is quadrant 4 where sine is negative. Rotate the negative of that. So negative 5 pi over 3 puts you in quadrant 1 where sine is positive. And then this is quadrant 4 to quadrant 1 again. So if we look at this, it looks like from these two rows, it looks like the sine of negative theta is equal to the negative sine of theta, which means sine is an odd function. And that's true, sine is an odd function. We're gonna do something to kind of prove that in a little bit, probably in the next video, probably not in this one. But right now, that's kind of the best we can do. All right, let's do these cosines. So cosine root 3 over 2, root 2 over 2, negative 1/2, negative root 3 over 2. Another negative root 3 over 2, negative root 2 over 2. What am I doing cosines? Positive 1/2, radical 3 over 2. Okay, so pi over 6. Now I'm going to take this in a slightly different way. So do this, do this. Okay, so we got A, S, T, C. All right, so pi over 6 is in quadrant 1 where everything is positive. Negative pi over 6 is quadrant 4 where cosine is positive. So the cosines should be the same of cosine of pi over 6 and cosine of negative pi over 6. They're going to be the same. So pi over 4 is quadrant 1, goes to quadrant 4. Cosine is positive in both. 2 pi over 3 puts us in quadrant 2, but the negative of that puts us in quadrant 3, and cosine is negative in both of those. So this is actually going to be the same. And then 5 pi over 6 is the same story. And then 7 pi over 6 puts me in quadrant 3. But the negative of that reflects over the x-axis and puts me in quadrant 2, where cosine is negative both times. So this will still be 3 over 2. 5 pi over 4 is the same quadrant, so same deal. And then 5 pi over 3, we've already seen that quadrant 1 puts you in 4, so quadrant 4 puts you in 1. So we're going to get the same again. So 1/2 radical 3 over 2. So from this, it definitely looks like the cosine of negative theta is equal to the cosine of theta, which would make cosine an even function. That's a big deal. Cosine's an even function. We need to remember that. You actually need to, that's the one you need to remember. Cosine's even. Let's see how the tangents work out. So pi over 6, so root 3 over 3, 1, negative root 3, negative root 3 over 3. These are all, you should definitely have these memorized. 3 over 3. This is part of why you want to memorize them. So you use them, right? Like if you don't have them memorized, you can't use them. So the people who tell you you don't need to memorize things, always look skeptically at them. Like, why are you telling me I don't need to know something? I don't really know what their end game is, but like, I always think they're talking from a place of privilege where like someone made them memorize it. So they don't know what it's like to not have it memorized, but they'll tell you that you don't need to have it memorized. But like, I don't know about that. All right, we're going to do the quadrant thing again. So let's see. Give me some axes. Some axes here. We got A, S, T, C. All right, quadrant 1 is here, and the negative of that is here. So they're all positive in quadrant 1. Only cosine is positive in quadrant 4, which means the tangent of negative of pi of 6, tangent of negative pi over 6, is negative root 3 over 3. And at that point, you know enough, right? Because I told you that it's either even or odd. As soon as you see that the tangent of negative theta is the negative of tangent of theta, you know what to do. So I'm actually just going to fill these all in. So, because it has to follow the pattern. Like it can't sometimes be sort of even and sometimes be sort of odd. Like how would that work? So here, I know we kind of blew through that one, but it's worth it. You can do it. Half of math is like making patterns, right? And we found one is equal to the negative of the tan of theta. I mean, maybe we should have done 2 of them at least, just to like make sure, but I'm confident. Also, I know the answer already, so that's part of my confidence on this. So odd. Okay, so based on the table, which trig functions are even and which are odd? How did you decide? So I'm going to say that even and then odd. So I think that the even function that we found was cosine. Now, if a function is even, its reciprocal is also even. So cosine is even, that means secant is also even. So cosine and secant are even. Every other function is going to be odd. So sine, cosecant, and then tangent, cotangent. So I mentioned before, the one you really have to remember, the one that I always remember, cosine is even. If you can remember cosine is even, that means that secant must also be even, and everything else is odd, and you just kind of like let that go. So this is a lot of work. It's a lot of thinking more than work, really, because you got to remember everything. But what I'm going to do is I am going to stop this here. I will come back in the next video and talk a little bit more about this and a slightly better way we can do it, but it's also a slightly weirder way. So I'll be back in the next video to do that for you, and I will see you there.